So Oliver Meinhold, he's the technical director of the Brewery Division and consultant to Zee Loeffler. He studied at the University of Munich, graduating with a diploma in brewing science and Berlin Institute of Technology, where he received his second master's degree in industrial engineering. He spent 7 years at the VLB Research and Teaching Institute of Brewing in Berlin as a project manager, followed by 7 years at the Berlin Institute of Technology as an assistant professor. He is in his current position for 13 years. He is a current member of the MBAA Higher Education Committee and the vice president of the MBAA District Mid-South. One thing I'll let you know about Oliver, he is a wealth of knowledge when it comes to cleaning practices in the beverage industry and improving your efficiencies. So the one thing I think we could get a great takeaway from his presentation is how to become more efficient when it comes to our clean in place practices at our facilities. We all know how to do SIP cleaning practices. I think this is just a great way to understand how you can improve your efficiencies when it comes to water conservation and chemical use reduction. So Oliver, you're more than welcome to start.
All right, everybody. I hope everybody can hear me well. Thank you for the introduction and thank you for giving me the capability to do this presentation. So I would like to step right into. Everybody knows a calandria is basically a cooking device. It's a bunch of tubes which are surrounded by steam, and then you heat up your liquid. As you can see, there should be a nice shiny stainless steel equipment, but with the boiling of the mash or the wort, you can see some fouling on it, which needs to be removed after to increase the efficiency. Another typical picture after finishing a fermentation and emptying the tank is like when you see here on the tank in the part where the liquid was, then above was the foam from the yeast and everything. You saw your spraying device from the CFP system, clearly visible. It was all fully submerged. So most important is to ensure that in this case, the rotary jet is functioning, before you start your CFP. Otherwise, the CFP will be not successful. So what is CIP? Cleaning in place is basically a definition of a method without really changing a lot of your equipment. You don't have to dismantle a lot of things. You don't have to rebuild things. The idea is that you have a setup system. You might have to change some swing panels, or you have to open or close some valves. This way you can easily run a system. It is always used for interior cleaning of all your equipment, if it's your mash tun, if it's your wet kettle, if it's your fermenters, bright beer tanks, etc., your fillers, and so on. So this is very important, and the idea is that first of all, it's very safe because you don't really touch much of the chemicals. You're remote of everything. It is very economical because the system is highly automated, or should be highly automated. So you always have the same amount of water, you always have the same amount of chemicals. So the consistency is one thing. So that is a big advantage. If you look at CRP systems nowadays, the kind of colorful drawing and you see on the left side, that's a pretty fancy version. You can see 5 tanks. Most CRP systems start with 2 to 3 tanks. 5 tanks is pretty fancy. And you can see actually 3 lines here. That means at the end of the day, you can run multiple CRP cycles at the same time with different pieces of equipment. That is like really high end. And here's a picture of a valve block. Some of these huge breweries or facilities, they have blocks of this size where you have 600, 700, 800 of these valves. So it's a pretty complex system, and without a computer, you would be basically not able to run such a system. More common in the smaller beverage industry are these little skids, like you can see on the right-hand side. This is a 3-tank skid, which is, nowadays very efficient. You have one supply pump, you have one return pump, but this is already a equipment where you can do really well, consistent cleaning. The opposite of CIP is COP, is cleaning of out of place. That means you do a lot of things manually. You have to disassemble a lot of things, which of course is much more depending on the individual person who's doing it. So first of all, do you break it down fully, or do you just leave a few pieces together? That is already a problem, or can be a problem. Independently from that, if you have a complex system which is run with a CIP, it is always recommended here and there to take parts off and manually clean them and scrub them, because the CIP has its limitations. Problem of the COP is you're much more exposed to the chemicals, so it's hazardous stuff. Of course, you should wear all the proper PPE. It is very time consuming. Imagine you have to grab every piece, scrub it, rinse it, and so on. And, we're all humans, so it's very inconsistent. So you have different results in the cleaning. So when you look at, I will step a little bit in the theory of cleaning, because that's kind of helpful to understand when we start later on talking about, where you can save stuff and, make it more efficient, more sustainable. We have basically 3 parameters which have an impact on your cleaning. That's equipment, it's the system, and the operational parameters. Equipment is actually, that's when it starts out from the beginning. So when you don't have a facility yet, or you have a small facility and you're planning a new one, this is where you really can start implementing a lot of points where the efficiency of your cleaning, the efficiency of the water usage or the chemical usage really becomes a big advantage. So when you plan something, when you design a system, make sure it's always hygienic designed. It's built in a way that it's easy to keep it clean. And if it's some simple things like a sloped floor with tiles, with a nice drench drain, so you don't have to have people running around with squeegees and pushing the water uphill to get it drained and stuff like this. Next thing is the material. Try to use material which is chemical compatible, so you don't really have to look into, oh, I can't use this chemical or I cannot use that chemical because whatever soft metal, plastic is not resistant to this. So very important that when you look for equipment, that the proper materials. If you go out now to these standard bigger manufacturers of equipment, they all know this stuff. Of course, a smooth surface, a minimal electrostatic binding forces, that all helps to reduce the effort of cleaning. So if you have a smooth surface, the adhesive forces of this, the fouling to the surface is smaller, so you need less cleaning, less water, less time, and so on. So very important when you start planning your facility, keep in mind, I know cleaning is not very sexy, brewing and distilling is much more sexy, but get this also in consideration that when the planning is how to clean everything, do you have walls? Ideally, if you want to have multiple divisions, multiple departments in your production facility, separate them. You really make walls and doors in between. I know sometimes it's not as beautiful in contrast to an open concept, but if you separate things, tendency is that things get dirty, it's much lower, so the effort of cleaning is also much more reduced. If you have an outside door, make sure you don't have like wind blowing in leaves, or when you step that you have a nice surface of your sidewalk, so you don't bring in all the mud on your shoes and so on. There's all these little itty bitty things which sum up at the end, and like I said, this is everything up front in regards of when you plan something. Once you're done, you have the system parameters, which basically then is part of the regular operation. Here we start with the chemical composition and the deposit of your equipment. So chemistry is not equal to chemistry. There is simple chemistry, more complex chemistry, with some fancy additives inside. And also how much fouling, how long do you wait before how many batches are you running before you start cleaning? Or is like when you look at the brewing industry, when you make a simple light beer versus a very heavy porter or so, that is already a big difference in respect of how much buildup you will have of fouling and how much effort you have to put into the cleaning. Frequency of sanitation, cleaning. How often are you doing it? Normally it should be done before it gets problematic and difficult to remove all the fouling. So depending on your production schedule, depending on your type of products you produce, you should adjust the CIP. If you have, like I said before, very heavy beers, maybe you have to do it every 3 batches. When you have a very light product, maybe every 8 or 9 batches you start cleaning. Then the soil of the cleaning solution, that's also very important. If you have a CIP system where you cover your CIP solutions, how much soil load is actually in this cleaning solution. That's, also helps you to determine when it's time to, dump it and make a fresh batch. but that makes a big difference too. If you have like a strainer up front, which takes out the majority of the solids, so your cleaning solution will last you longer. Process water, the quality ideally in this particular case is the hardness. The hardness is something, the more calcium magnesium you have in your water, the more difficult it gets especially for the caustic. You need then chelating agents, etc. Ideally is if you have soft water, because then your chemistry will focus on the fouling and not so much focus on the hardness of the water. Environment of your brewery or distillery, whatever, that makes a big difference. Is it a hot environment? Is it a humid environment? Is it a cold or dry? If you look at facilities, let's say in Texas or Florida, where you have high temperatures, high humidity, if it's an open concept, you always have condensation, you always have a biofilm formation. Whereas if you're in the Rocky Mountains, Colorado, Montana, where 10% humidity is already, that's pretty high, you don't even know what mold is. Everything is dry. You don't have to worry about biofilms and so on and on. And then last but not least, CIP equipment itself, how well is it equipped with automation, how many sensors, what type of sensors are in there, to help you to optimize your CIP process. If we look at the theory of cleaning, Mr. Sinner, a German guy who came up with the cycle, basically we have 4 parameters. We have the concentration of your chemical, we have the temperature, we have mechanics, and the time. This is a good way to play with these 4 parameters to see which one you focus on, which one you're looking for. Mechanics is pretty much given. There's not much you can do because the spraying device inside, mostly a static spray ball in your tank, there's not much you can do. That runs at a certain flow rate with a defined pressure. Otherwise, if you go too much in pressure, you will start, vaporizing the liquid, so you don't get the liquid to the tank wall anymore. If you just turn it down too much, it will just dribble out and you don't get the liquid to the tank wall either. Temperature, that's a nice factor. If the warmer the caustic, the more efficient it will get. So once you get past 135, 140 degrees Fahrenheit, a caustic cleaner significantly increases in its efficiency. Maximum temperature 175, 180. I'm not going higher than this. And there is kind of a rule of thumb. If you increase the temperature by 10 C, which is about 18 Fahrenheit, you double the chemical reaction speed. Theoretically, you are able to reduce the time by half. That's kind of a theoretical thing. The reality is quite often different, but the higher the temperature, the more efficient. Same as concentration. The more chemicals you use, the faster the cleaning takes place, the less chemicals, it takes longer. And this is how you can play it. If you focus on, I want to be very sustainable, I want to be very cautious on the water usage and the chemical usage, but I have almost unlimited amount of time, just reduce the temperature, just reduce the concentration, just let it run longer. If you have equipment, or your production is really tight, the tank turnover of your tank is very tight, you only have 2 to 3 hours, so time is a limiting factor, then you have to go high in temperature and high in concentrations. But just coming back from the old days to nowadays, if you look at home at your washer or your dishwasher, nowadays some of these dishwasher turns are 2.5 hours. In the old days it was 30, 40 minutes. But with these parameters, you can make your efficiency in regards of energy consumption, water consumption, and detergent consumption much more efficient. I will talk a little bit about mechanics because this is something, especially in pipes, just to give you an understanding about the difference between laminary and turbulent flow. So if you have liquid running through a pipe, the speed going through is very important. If you go too slow, you basically have a smooth run of your liquid. That would be then the upper picture on the upper left corner. So if you kind of cut up your liquid into indefinite amount of layers, the layer actually at the wall of your pipe has a speed of 0. So there is no mechanical action. The fastest point is in the center of the pipe. So if you then increase the pump speed and you get it beyond a certain speed, then the laminary flow will turn into turbulent flow. So basically you have a lot of internal vortexes. So now you have actual mechanical action at the tank wall. And to give you an idea to determine this, you can have either flow meter which is built in, or you can rent a flow meter which you attach outside of the pipe, and then you can read it. So here's a little calculation. You can Google that find it. Reynolds is a number which is unitless, and depending on the speed, the viscosity, the kinematic and dynamic viscosity, the diameter of your pipe, the flow rate of your liquid, and so on. It's a pretty simple way to determine the Reynolds numbers. And if you look down in the arrow where we have laminary, transition, turbulent, so you want to be always above 4,000 Reynolds, then you have a pretty guaranteed turbulent flow. If you get below 2,100, it's a very smooth run, a fully turbulent flow, and then in between it's a transition. It's kind of hard to say, do I have a turbulent flow or is it only a laminary flow? As a little information, just because quite often you see that the diameter of your pipes is changing, the further away you might go down in diameter. Ideally, you don't want to change too often the diameter of your system because, the bigger the diameter, the flow rate is the same, but the speed will slow down. And so you always want to make sure that at your worst point with the highest diameter, you still have the proper flow, that you have a turbulent flow. So just looking at pipes from DNA, which is 80 millimeters, which is a little bit more than 3 inches, going up to 100 millimeters, which is 4 inches. Originally, you have a 2 meter per second, which is about 6-7 feet per second. It drops down to 1.25 meters per second, which is about 4 feet per second. So just as a side information of that, make sure that when you install everything, and that comes back to the planning, that you keep your pipe diameter as constant as possible. If you change it, don't go extreme, do small increments. If you go like from a 1 inch to a 4 inch, then you really have issues. If you go from 1 inch to 2 inches, that is not as complex. Here's a picture of an example, same pipe, same situation. That was done on purpose. The left picture shows you basically when you don't run with sufficient speed. So the pipe wall didn't get clean, whereas then when you turn up the speed and you get in a really nice turbulent flow, as you can see, the pipe wall is nice and clean. Water saving. So this is something which is becoming more and more a big topic, and especially right now in the beverage industry, we all have, basically a reduction in sales. Many companies are kind of struggling a little bit, so they are now starting looking more and more into various parts of their facility and how to save water. So one thing is when you have additives to your CRP chemicals. So a surfactant, which helps, for example, to reduce the surface tension or to reduce the viscosity. In other words, the chemical is easier to penetrate into small cracks and crevices. A chelating agent, that is something when you have a lot of hardness and everything in there, that kind of binds it and basically makes the hardness not impacting your cleaning stuff. Enzyme-based solution, that's a complete different approach. This is something which you can, use if you have specific, like when you do juices and you have a lot of pectin of apples or so on your equipment. A pectin or pectinase, an enzyme, would be great for this. Or if you have, some starch or protein, basically enzymes which degrade starch, which degrade proteins, would be ideal for this. Keep in mind, these enzyme-based cleaning solutions have mostly a very specific temperature. They work best. So you need to, and pH meter, so you have to adjust this CRP solution to that specific parameters, but then it's a very, very nice cleaning solution, and the beauty is it's not corrosive. Sometimes it might take longer, so you have to take this in consideration, but that's a nice additive to your CRP. Also, when you have certain surfactants in there or additives, your rinse cycles will go down. So you don't need so much water anymore to rinse out your chemical, because you want to always make sure when you switch from your caustic to the acid that you have not too much caustic left because that would basically neutralize your acid and reduce the acid efficacy. So the rinse cycles are very important. There are all the other additives, which are more like for beer stone or milk stone, which are very strong. But like I said, these additives, I would always ask your vendor what specifically you really have to attack. So knowing your individual facility, what is the consistency, what are the materials, organic, inorganic salts of your fouling, of your scaling, and then you can actually dial in your chemicals so it's much more efficient, and that helps you to clean with less water and energy. Water is very important. Of course, the more you use, it's money factor, and it's an environmental impact. Sometimes I come to customers and they say, "Hey, water is free for me," but then at the end they have a little, wastewater treatment facility, and I say, okay, but that's not for free because you have operation costs, you have people running it, and every additional gallon of water you put down the drain, increases the cost of treating it. So start from the get-go and make sure that the water usage is optimized. Here, for example, the breweries, they say 1,000 gallons per cleaning cycle. That depends quite often on the size of every facility. No matter, it's not only a brewery, it's also, for every other beverage industry. The larger your batches are, the cleaning will be more efficient per unit of your produced product. So when just as a few numbers from the brewing industry, we always calculate how many barrels of water you need in this total operation to manufacture 1 barrel of beer. So really high-end breweries, large breweries, they are below 3 barrels of water per barrel of beer. Smaller breweries definitely will go up 5, 6, 7, 8 barrels. There's a lot of potential to save, but the scaling is one thing where you have quite often the issue that you cannot do this, and then there is a problem. But as an example, if nowadays when you look at the new additives you have to make beer, like a hop oil product, which enriches your beer with very intense hop aromas, the oils are not easy to remove. In this particular case, you need the solvent-based cleaner. And so, like I said before, when you discuss with your vendor about what fouling, what material you're facing, then they can actually help you to pick the right solution. When you add additives, you can shorten rinse times. In other words, you have less water because the rinsability of your product, of your chemical product, is much easier. The surfactant, soil removal, that is also. Scale build up, so a chelating agent, will help you not to have so much precipitation of calcium magnesium out of your water, which then will remain on the tank wall and everything, so you might have less acid cleaning afterwards. We have customers, they don't even run an acid cycle every time. They have such soft water and reduced calcium magnesium in your process, so that they have to do it every 3 to 5 times. So you can actually kind of look in advance to see how can I actually reduce. Maybe I don't have to do it every time. Also, energy use, concentrate additives. We try to come up with a very strong concentration, so you have to dilute it significantly on site, but that helps you to, first of all, from transportation. The more diluted the product is, the more you actually ship around water, which is inefficient. At the truck and everything. But also, if you have very highly built concentrated chemicals, you can also run them at lower temperatures. You're saving energy, but also will help you to reduce other parameters. What is the benefit of saving water and CIP additives is less water, shorter cycles. So the pump doesn't have to run as long, so you're safe in utility bills, your downtime, all the stuff will be reduced. Sustainability, enzyme additives, bio-based stuff. So with all this stuff nowadays, people will go more eco-friendly, will be more cautious towards the environment. There are more and more additives products coming out which cater to that, which is very good. And then also, depending where what kind of product you're making, how much the FDA is part of this, how much the FDA is controlling you. So they also help you to favor more and more towards these products. The beauty is that a lot of these things are very identical. So various industry, if it's a brewery, pharmaceutical, and so on, they can utilize each other's products with maybe small minor adjustments. Pharmaceuticals is a little bit different because that's a lot of all the documentation included. They have much stricter rules. They have much more testing. So that's a much more complex topic. Dairy is another hot topic, because it's a very product which can have a lot of dangerous germs in it for the customer. So you want to make sure this is proper. Breweries are pretty safe because they have a product, as long as it's not a non-alcoholic beer, which is pretty biostable. It means there are no real pathogenic germs able to grow in a low pH environment with alcohol, with CO2, with hop products. So the beer itself is a pretty safe product by itself. What is, choosing the right additive? That, like I said a little bit before already, there are a lot of needs coming from the client, coming from the CRP system. So it's very important for your vendor to do a good audit upfront to see what you need. Surfactants, most of the non-ionic surfactants are the best ones, which help to reduce the surface tension, which help to reduce the viscosity. So surface tension is important because the last thing you want is that when you run a CRP cycle that you build up a lot of foam, because every foam inside of a tank takes more water to be rinsed out. So you want to have a non-foaming chemical. Also, when you have a lower surface tension, the penetration into your fouling is much faster, so you save in time and will crack it open faster and basically break down everything. Chelating agents, one of the most famous one is EDTA or other gluconates. They are basically in charge of removing the hard water parts, so that also helps you to reduce the rinse cycles in dairies, breweries, and so on. And then if you have an enzyme-based additive, they specifically break down, like I mentioned before, protein, starch, and other stuff at low temperatures. So these are really good for food processing facilities. These are also good if you have like sensitive material, like from the production facility, because enzymes are not corrosive. They're mostly very neutral, but they are very efficient, but the time tags. Then if you have industry-specific applications, from reduced water usages, what is the high demand sectors, breweries, of course, like I said before, low foam surfactants, chelatings. Dairies is more enzymatic. You can do a lot of degradation of milkstone with enzymes. That also helps to conserve water in the CRP system. In food processing, many things is now bio-based. When we talk about so-called non-rinse sanitizers, or where you have now products which have like an NSF H1 categorization. So these are ideal if you have an incidental food contact, and that helps you to make sure that this is not really harming the consumer. It's not meant to be that it is a food additive, but if accidentally things will get in contact with the food, it's not a problem. Pharmaceuticals, that's a much more complex, the GMP compliant additives. So this is a much more complex topic, but we talk more about beverages. When you look at typical CRP programs, here we can start already saving quite a bit of water. I see a lot of people who pre-rinse, basically by removing all the loose material with, 15, 20-minute rinse cycles. Way too much. We say 2 to 5 minutes. Mostly we recommend just burst rinses, let it run 45 seconds, wait a little bit. So give the water time to come down, bring all the loose material, repeat that for 3-4 times, and you're good to go. Then you have, in most cases, because the biggest amount of fouling is organic substances, so the caustic, like I said, if possible, go up to 70-80 C, which is like 158 to 176 Fahrenheit. Run it for, depending on, the equipment, if it's a keg, maybe 5 minutes is sufficient. But, 30 minutes, But like I said, that needs to be evaluated individually because everybody has a little bit different equipment. Everybody has a different type of product. So there is no rule of thumb. When you do it this way, that's perfect. You need to kind of evaluate this by your own. Then rinse with water real quick. Helps, when you use ambient water temperature to kind of cool down the equipment, but also make sure that your caustic is fully rinsed. Ideally, if you have a CRP cycle, you push back the caustic with the rinse water. In the return pipe, you should have a conductivity probe. As soon as the conductivity probe sees a decrease in your conductivity, that means, okay, we are now starting to see water instead of caustic. So then you redirect the water back to the drain because you don't want to dilute your caustic. You can also do some pH meter in there. When you get close to neutral, you can say, okay, we can stop it. So you can do a lot of things to optimize it to reduce your water consumption. Then the acid cycle comes. That is, mostly a very mild 1.5% solution at ambient temperature from 10 to 20 minutes. Like I said before, it's just to remove this little bit of inorganics, which is coming from the water, which is coming from the product, if it's, beer stone, milk stone, and so on. That helps you a lot. And then you rinse again. Acid is mostly easier to rinse out than caustic. It's not so thick. It's not so, resistant to be rinsed. Again, like I said, either you control it with conductivity or pH. And then last but not least, your surface sanitizer, ambient temperature. Mostly you want to have an oxidizing sanitizer, which really destroys your microorganisms. And if you look at a sanitizer like a peracetic acid, the time of doing the job is 30-40 seconds, but I still recommend at least 10 to 15, sometimes, in small kegs, maybe 5 minutes. What you want to achieve is that every spot of your equipment really gets the 30-40 seconds of your sanitizer. CRP automation helps you also, that makes things much more consistent and everything. That's very important, the more you can control it, the more the system is controlling it. It will always ask for the same temperature, it will always ask for the same amount of chemicals, and so on and on. But make sure that you validate it, that you audit the system on a regular basis, because you have all these fancy temperature, conductivity, flow meters, all these sensors in there, but one day they might go out, one day they might just be off, which needs to be recalibrated. So automation is beautiful, but you have to make sure if it really is what it is. If you just take a sample, measure the temperature, do a titration, is the concentration you want to have? Oh, it's not. So maybe you have to look at the conductivity probe and so on. So to improve your utilization is, like I said, chemical blends, concentrations, and the dosing is very important. Monitor all the volumes, tank levels. Ideally, when you have a fermenter, basically a cylindrical conical tank, you want to make sure that the amount of liquid at the bottom of the tank is high enough that when the return pump pulls it out, it doesn't suck in air, but you don't want to have too much in it because then it takes longer for the liquid to drain. That the time basically then enables for the solids to precipitate. So it's kind of a nice, game to find the optimum level. Spray heads, maybe you can, instead of a static spray ball, do rotary jets, which have also more impingement. The impingement is an addition of mechanical action that helps to reduce the time, that helps to reduce the chemicals because you add more energy to it. Non-sanitary fittings and seals, all this stuff needs to go away because that makes it more difficult to clean. You have to take them out. You have to basically manually scrub it and sanitize it. So that will take time, that will take extra water and so on. Adjusting cycling times, just look at, when you can do a visual inspection, when you do the, from the lab, you do some testing afterwards. How well is it done? See if you can reduce the time, the temperature, the concentration. If you do this, make sure that everything is properly controlled by the laboratory. Otherwise, you think, oh, it's much better now from the timing, from the savings I have, but maybe your tank is not clean. So make sure when you do changes, do a close observation, always control everything. And once you have constant results where everybody's satisfied in your facility, then you can start reducing the controlling. One of the biggest parts is recovering and reusing your cleaning solutions. I know many small facilities, they don't have the financial power, they don't have the place, room, and so on, to have like a CIP system or anything where they can actually recollect the liquid and reuse it again. So once you have the chance, a CIP system, you can recover the liquid, make sure you don't dilute it down. When you have good controlling of it, you can basically, when you push the water with the acid away, that the acid doesn't push the water into the acid recovery tank, so it goes to the drain. Once the conductivity goes up, you can actually then redivert the acid back into the acid tank. There are many, many possibilities. Another thing is, when you want to increase or decrease the flow rate, instead of just having a valve which you kind of throttle open and close it, use variable frequency controlled pumps. That makes it much better. It's much more efficient than just having a valve throttling, things like this. That will create more problems. And then ideally is that you have all your people properly trained. So when you do things, when things happen, people know why it's happening. People know what's going on during the process, and then monitor it in record keeping. Take samples, make a note, put in the titration. What is it? Is it in alignment with your concentration, what the conductivity meter tells you? This is very important, so that helps you a lot. So when you look at the most important points of a CIP, we have the time, we have the temperature, we have the flow, pressure, flow pressure, which is basically the mechanics, and last but not least, the concentration. So always make sure these variables work with each other to get the optimized CIP. Always record everything, all the variables, verify them, take the sample. When you do quality checks with swabs, when you take rinse water, if you put them on a plate, make sure that always each CIP cycle gets its specific test results, so you can see, put them in an Excel spreadsheet or whatever database you have available. Look at this, make curves over the time. Maybe you can see trends. When the trend goes negative, you have to do something. Very important, I mentioned it to the beginning, how to design your CIP system. That is already the most important part. Get the proper tools, get the right tools, make sure that everything is hygienic design, the right materials. Mostly it's a little bit more expensive, but over the long run, the savings, and especially on aspirin for no headaches, is significant. So, like I said, add-ons expensive, but make sure that you have to do it right. Sometimes people over-engineer things, might be a little bit too difficult, then you have more problems. But if you talk to the right people of the manufacturers of equipment, they can help you. Conduct tests, dye test. You can spray on. It's a kind of a bluish liquid. You spray it on. It's mostly an alcohol-based system. The alcohol evaporates. Then you see everything in blue, and then let your CIP run and check where you still have blue remains. That means you have a spray shader, or your spray ball has clogs, or there must be some mechanical deficiencies that certain parts of the equipment doesn't get cleaned. Do this on, periodically, just to make sure that all your equipment is properly working. Dead legs, very important. That's one of the biggest problems I see quite often, especially when people buy used equipment. There might be some pipes which had a function in the past. People just took it out, disconnected it, but left the pipe there. So once you have a dead leg, which is kind of defined as if you have twice the diameter far away, the idea to get the liquid in the dirt in this little dead leg out is getting very difficult. So cut it off as close as possible and make sure that, you have either a shut-off valve, or you just cut it off and you kind of seal a blank metal over it and make it rise nice and smooth. Very important, quite often I can see that on floors here and there, a little bit more simple equipment. When it's not perfectly done, you see puddles. Number one, if it's outside, when all of you might have experienced this already, if it's the water, standing water, you will have, biofilm formation. It gets very slippery, so it's more like a dangerous situation. But all the inside of your equipment, if there's one little dent where you continuously have liquid standing, that means you can always have something growing there, and it creates, problems, sanitary issues and so on. Turbulent flow in your pipes, we talked about this already before. Make sure that you always have a turbulent flow, otherwise, you don't get the pipes clean. If you install something, always make sure it's self-draining, so you have always pipes a little bit sloped, and so on, because if you have standing water in there, it's like number 6, puddles, you have a possibility where bacteria can grow, especially if it's, not the cleanest water and so on. Gaskets, don't over tighten them, make sure they're, not leaking, but if you over tighten them, you will start actually destroying them, and then they will start leaking faster. Here and there, I would recommend replace the gaskets, make sure do a visual inspection of gaskets, especially if you have like a butterfly valve, the internal seat. I've seen some really horrible seats which were already heavily chewed up, and there were so many cracks and crevices where microorganisms can harbor, and you can clean and clean and clean, but it won't work. So make sure you always look at these gaskets and replace them. Trust your sense, just look at everything. Like I always said, we all test our products. We, organoleptic, we drink our beer, we test the wine, we test the spirits, we are very well trained, we know. But you have much more senses, look at things, feel at things, is it vibrating, is it making squeaky noises, and so on. So if you walk into the facility every morning, you have a certain picture of everything, Does it smell? Oh, it smells burnt. Maybe some rubber gasket is running dry and starts heating up. So stuff like this, make sure that you always get a picture of a right, properly functioning, and if something off, it will let you know. You can feel vibrations. If there's an imbalance of a agitator, you can, like smell something. You can see something leaking and so on. So make sure that this is immediately taken care of, because leakages is another problem, which I see quite often. People don't take care. Water loss, chemical loss, product loss, etc. So this is something simple, and make sure that you always report things to the proper people, maintenance guys, so they can take off any deficiencies. Thank you so much, guys. I hope I did it in a pretty fast way, because we don't have too much time, I was told, but please feel free to ask me questions now.
Yeah, Oliver, thanks so much, and you did perfect with the timing. Honestly, I haven't had a speaker that has, because we've got about 6-7 minutes left to do questions in the Mentimeter, so perfect there. We had a good amount of questions come in, so we'll try to hit those. The first one was, is the pre-rinse used to wet surface or remove some items?
It can both, basically. You can start, depending if you wait too long and let this dry on, the the fouling or whatever, then it's ideal for pre-wetting it, correct? But ideally, it is to remove all the loose stuff, so your cleaning solution at the end has not so much soil load. My recommendation is always, when you have a tank emptied, no matter how quickly you need it, try to clean it as quickly as possible, because the longer you wait, it's the same when you take your cereal bowl in the morning. If you don't rinse it immediately in the evening, the stuff is dried on and it's really hard to get rid of. So pre-wetting and easier to remove things when you do it right away. And the pre-rinsing is to save the CIP solution later on with longer usages, because you don't contaminate with so much material.
Awesome. So another one said, how do I know if my CIP system is actually optimized for water efficiency?
Basically, the more you can record values, how much water goes in, how much water goes out, and then if you look at your overall water consumption and look how much product you produce, like I said before, if you have a brewery and you use 8-9 barrels of water per barrel of beer, then there's a lot of room for improvement. If you're down to 3-4, you're already pretty well. But like I said, when you look at your cleaning solution, then you know how much the minimum amount you need to fill all the pipes, get the tank, the cone filled, the returning pipe, that amount of liquid, that is important. If you have twice as much liquid in your CIP tank, that might be a waste. I know some bigger breweries, they actually have for every tank a different amount of water they pump out, because every foot of pipe adds more liquid. So you want to make sure that you always have an optimum amount of liquid present. And, you know, even it sounds great if you have twice as much liquid solution sitting there, but it takes much more energy to heat it up. It takes much more water, and it takes much more chemistry. So when you look at this, how much actually water you need to, let's say, clean the furthest away or the biggest pipe length tank equipment, focus on that, and then it's easier to go down instead of up. But focus on this, and then you optimize your liquid. And like I said before, if you have proper chemicals with proper additives, you don't need so much water for rinsing and so on. So everything is, like I said in my presentation, pretty clear stated.
And this is a question that was sort of tacked onto that. It said, what measurements should I be tracking? Which I think you sort of answered that, sort of input versus output type deal, or?
Yes, and then although at the end, always important is check with the laboratory in regards of the quality of your cleaning. You know, if it's really clean, is it sanitized, do you see counts and so on? When you do a visual inspection, do you see your spots? This should be at the end your primary goal. How clean is my tank? If everything is clean, you can start dialing down once you hit the point of failure, and then you can, you know, basically optimize it to that. But very important, always make sure, like I'm emphasized too, that you use your lab very closely to monitor every changes, because it might bite you later on.
Awesome. One just came in. It says, are you implementing enzymatic cleaning in breweries? If so, in which applications?
In the brewing industry, there is at the moment, there are a bunch of cleaners used for outside cleaning, like drains, stuff like this. But at the moment, there are more and more enzymatic cleaners coming back for beer membrane filters, because here we have mostly a material which is not as resistant to strong corrosive chemicals like a caustic or an acid. You know, if you have like a polysulfone, ether sulfone membrane, you cannot really go with a strong caustic on there. That's where the enzymatic cleaners become more and more important.
Awesome. All right, well, we are going to, if everybody doesn't mind, we're going to run back to our Mentimeter questions. We've got only a couple more minutes left. Oliver, thank you so much for your sharing with us your wealth of knowledge, and we'll make sure that everyone gets the link to our recording that we took for this, so that if you missed something or you have some more questions, that hopefully that follow-up will be there. Also, to mention, in the follow-up email, we will be sending the video that Mark talked about at the beginning. We have a new video coming out that goes over our Sustainable Spirits program. It really encapsulates, you know, what our program is and some of our members. So, if everyone wouldn't mind going back over to Mentimeter, let's see. We'll go over here. We'll do our last question. So, some of these questions are very similar to what we asked at the beginning, but the hope is that that after this, you feel a little bit more confident in your knowledge of clean in place techniques. So, let's see. I know for myself, I learned quite a bit. And I wasn't so confident at the beginning, but now I feel a little bit more confident about these types of techniques. So let's see here. Give a couple more seconds. All right, about to move to the next one. All right. Which of the following clean in place additives do you think will be most beneficial for your facility? A couple more seconds. And I think this is our last one. How likely are you to implement some of these techniques into your cleaning practices? So 1 will be not likely, 5 will be very likely. All right, and I'm going to go back to our screen, but if you are still working on answering that, feel free to keep doing that, and it'll still take your answer without us showing the screen. But like I said, be looking for a follow-up email with a recording for this, and any of the things that we mentioned, we'll be linking those in the follow-up as well. Oliver, once again, thank you so much for sharing your wealth of knowledge, and I'm sure I'm speaking for Oliver here, but if there's any questions that you think of, you're having dinner tonight, you're laying in bed, you're like, oh man, I wish I would have asked the expert, I'm sure that Oliver wouldn't mind, you know, an email or something, reaching out to him.
Don't worry, just send me an email.
Well, let me make sure there's no more questions for everybody. Just said, thank you, great presentation. There was one more. It says, I think pressure can compensate for temperature, time, and concentration of additives. Do you think we should optimize for pressure over temperature?
Like I said, pressure is depending on your spraying device. If you have, you know, rotating jet where you're the impingement, then you have more pressure mechanical action inside of your tank. If you have a static spray ball, these spray balls work only at a very narrow window of pressure and flow rate, so there's not much wiggly room for this, because you want to have a nice closed curtain of liquid going down the tank wall inside. And if you push it too hard through the spray ball, you just, you know, atomize the liquid. You create a mist inside of your tank, and if you turn it down, you know, you might just dribble out. So there are limitations, but if you have a jet, then the impingement will definitely compensate for temperature, time, and so on. Yes.
Awesome. Well, thanks so much, Oliver, and thanks everybody for being a part of this. Once you receive the follow-up, if you have some ideas for future webinars or would like to even speak, reach out to us, reply to that email, and we're always looking for new ideas to help out our breweries, wineries, distilleries, and really just the beverage industry in a whole. So everyone have a great week, and we be on the lookout for that follow-up. Thanks.
Thank you.